Good morning, 201ers. This week we're going to do investment analysis along with any other questions or things that you want to cover or things that you thought would be useful since we only have this week left. So when we're talking about investment analysis, the basis of that is the time value of money. So the time value of money is based on two basic things. So number one is that a dollar today is worth more than a dollar tomorrow. And something called compounding. Now, so we're going to try to understand these two things. That's our goal for today, is to just really understand the basic theory behind this, but then some of the specific nuts and bolts. So first, let's start off with a dollar today is worth more than a dollar tomorrow. If I gave you the option and said, hey, I can give you $10 today, or come back this time next year and I'll give you $15. A lot of you would take $10 today. Even if I made that a much bigger number, I'll give you $1,000 today and I'll give you $1,100, $1,200, $1,300, $1,400, $1,500 in a year. Many of you would take the $1,000 today. That's really just your emotions are playing out why a dollar today is worth more than a dollar tomorrow. There's an old saying, a bird in hand is worth two in the bush, or a beer in hand is worth two in the fridge. It means what you have that is present is known, and that gives it inherent value over something off in the future that could be unknown, which is what we talked about in risk and uncertainty last week. So think about this scenario where I'm going to give you money today, or you have the option of getting it in a year. So what are the things that can happen between now and 1 year that would make you choose $1,000 today as opposed to a far greater amount, $1,200, $1,300, $1,400, $1,500 in a year? So what could those things be? Just kind of brainstorm. You might think of one thing that you've been hoping would happen to me all year long: death. If I die and we had a handshake agreement that I'm going to pay you $1,500 in a year, that's a problem. You're not going to get your $1,500. Why else are there reasons? Well, how about that thing called inflation? Now, a lot of people think inflation is bad, and that's not true. The type of inflation that's bad is unknown inflation or unexpected inflation. If you think, well, Tim's going to give me $100 today or $1,000 today or $1,200 in a year, and I think that prices are going to go up 5%. If that's the only thing that's keeping you from taking the 12 or whatever, how many dollars you decided is equivalent to 1,000, you should take the payment in a year, because $1,000 today would be worth $1,050 in a year if inflation was 5%. So we know prices are going to go up and the value of the dollar then is going to go down by the same amount. It's the unknown inflation that causes us worry. You know, we kind of build into our psyche this 1-2% inflation. We know prices go up a little bit. We build that into contracts. But if it's more than that, then we could have, issues. Okay? The third is opportunity cost. You might want the money today. You might like, Tim, you don't drink, you don't smoke, you exercise, you're not going to die. We're not that lucky. Inflation, in your lifetime, inflation's never been an issue. I'm not worried about these things. I'm going to take a much smaller payment today because you're a college student. Maybe you don't have any income, and $1,000 is a big deal. Or maybe you're a senior and you're thinking about these expenses that you're going to incur as you transition from college into your full-blown adult life, and you realize, man, life is expensive. I need the money now. In a year, I'm going to have some steady flow for 12 months. I'm not going to need the money then. It's a matter of, I want it now. The feeling of immediacy is strong and not wrong in that scenario. It just is why money today is worth more than money tomorrow. It's something that we're born with. We really, really understand that, I believe. Okay. I feel like you should be able to check off $1 today is worth more than $1 tomorrow. How much is an important question. These three things form the discount rate. They put that rate together. If inflation is constant at 2%, we're not going to see interest rates below 2%. Depending on, and this death, what we're really talking about is just risk and uncertainty. Depending on what the investment is, depending on what the likelihood of the payout is, depends on how much we're going to pump up this discount rate in direct proportion to how much risk there is. An opportunity cost is really a comparison to other investments. So here's what I'm talking about. A salesman comes to your place of business and offers you some sort of magic elixir, some sort of investment, just some random thing that suits your example. And the cost is $1,000. So when we start looking at something called net present value analysis or investment analysis, what we're looking at is really a timeline that starts today, and maybe we have an investment that pays out at the end of this growing season and at the end of the next growing season. And so if we are looking at the cash flows, which here is where cash flows and profit are really coming together. So if you were concerned about, hey, these two things, profit and cash flow, have to reconcile at some point, here you go. Right, so let's say that the magic elixir costs $1,000. Our cash flow is negative $1,000. And the salesman says, guaranteed to increase profits by $550 each of the next 2 growing seasons. So we've got plus 550 here, and we've got plus 550 here. Our goal is to understand, how do we take these 2 positive payments and take them back in time and compare them to our cost that we have today. This negative 1,000, that's darn well known. I mean, it's explicit. $1,000 is going out. This 550, we're not so sure. Okay? Now, this problem is pretty simple, but figuring out what the discount rate that we should charge becomes a little bit difficult because we don't know what the magic elixir is. Maybe you do know exactly what the magic elixir is. Maybe you apply it every year and you know that this is well known, in which case it's likely that this is going to be an investment that has a positive net present value, which gives us the go-ahead. But if there's all sorts of unknown, then we might look at this with some questions and realize that it's probably not an investment that we ought to consider. Let's think about an alternative investment. The alternative investment is that you buy a certificate of deposit at the bank. And this one, you put your $10,000 in, and you can't take it out for a year. And in 1 year, you have $10,250 because the interest rate that you're earning is 2.5%. So 10,000 times 0.025 is $250. This is our simple interest calculation, just a percentage, you guys understand that. So now I'm comparing this, would I like $10,000 today or $10,250 in a year? Now this is a very low rate of return. This rate of return is how much are you earning on your investment. These are terminologies that are in the textbook. I'm not going to define them. You can read. The rate of return for the year is just 2.5%. It's very easy to calculate when we just have one payment. So this 2.5% is the interest, or is the rate of return that we have to compare to, well, what is our required rate of return? And in this case, our required rate of return may be very, very low. The bank investment is guaranteed. We don't think there's going to be any inflation. I don't have anything to do with the $10,000. I'm going to put it somewhere that at least keeps up with inflation and maybe a bit more. So in this case, when we think about what goes into our discount rate or our required rate of return, things are kind of synonymous. So just think contextually and ask if it's confusing. My required rate of return compared to the rate of return depends on how much risk I see, how much opportunity cost I have, and so on. So let's think about this $10,000 again. If you have the $10,000 and there's an investment opportunity, maybe it's something like ethanol plants was something 15, 20 years ago a lot of farmers were investing in. They certainly were offering a greater than 2.5% rate of return. You might say, hey, look, I've got an opportunity to make 10% with more risk, or I can put it into a certificate of deposit and make very, very little money at all. In which case, then, this doesn't look so good. Or, hey, banks aren't guaranteed anymore. This is not the case currently. But if bank investments weren't guaranteed, I need more than 2.5% for you to use my money for a year before you give it back. Okay? So let's check off number one. If you have any questions at 9:30, certainly respond to those. Okay, so let's go to number two, compounding. Okay. Compounding is, I think, the best definition is just remembering interest on interest. That's it. And then with what goes along with compounding is discounting, which is just reverse compounding. Okay. So we're going to start off with compounding because compounding should make pretty logical sense. And then that will give you to the step of discounting in multiple periods, which isn't quite as logical to begin with, but if you get compounding, then you'll have it. So if I put $100 in the bank today, and it's year zero, and we're going to say that our interest rate is 5%. Now let's make it 10%. We'll make it a little bit easier on me. And we'll make this $1,000. And then I'll get into decimals and fractions less quickly. And we'll just do this as long as I can do it in my head. Okay? After year one, we have $1,100. And I bet you knew that. After year two, I have $1,210. And this is where interest on interest comes into play. My $1,000 was my original investment, and I earned $100 on that. So this $1,100 to get to $1,210, well, I had my initial 1,000 times 10%, which was 100, plus my 100 of interest that I earned gets me to $1,200. So I have my 1,000, I have my 100, I have my second 100. But remember, this second 100, it earns interest too, because it's yours. So the interest on interest is maybe misleading because really it's not interest anymore. It's now investment, or what we call principal. The $1,000 is what you put in. The bank deposited $100. You got $1,100, and you're leaving it in all of these scenarios. You're not taking the interest out. If we were taking the interest out, then you'd earn $100 every year. It would be very, very simple. This is still not that complicated. We just have to remember, oh, I'm taking 10% by my new value each year. So at the end of year 3, I have my 1210 plus 10% of 1210, which is $121, or $1,331. And then next year, I'm going to earn $133.10, and my brain gives out at that point. Okay? So we're earning 10%, but it's on top of the interest that we're earning. One way to simplify this formula is to think about what we're really doing. We're really saying the future value of the investment is equal to 1 plus I to the n. And this is the future value of $1. And it's all, I remember being a college student and learning this for the first time and thinking, why do they always do this with $1? It's because you can scale it up to any amount. So it's this times the payment. So I'll show you how this works here in a second. Let me find my big pink calculator. All right, so what's the future value of $1 at 10% interest for 3 years? Well, this is what we have. My future value, sorry. My future value is equal to the present value times 1 plus I to the n. So this is that dollar, and then we can just use this formula for any amount. Okay, so let me repeat that. What's the future value of $1 invested at 10% interest for 3 years? Well, my future value is equal to the present value, which was $1, times 1 plus the interest rate, which was 0.1, to the n, and that's the number of compounding periods, which in this case was 3. So if I put in 1.1 to the third power, this becomes 1.331. So if I take $1 times my 1.31, my future value is equal to $1.31. If I'm asking what's the future value of $1,000 times $1,000 at 10% interest for 3 years, then this is just 1,000, and I take that times my factor, and I would get $1,331. Okay. So let's do another one. Let's say, what's the future value of $500 at 2% interest for 20 years? So my future value, what this 500 is going to be, is equal to 500, that's the present value, times 1 plus 0.02 to the 20th power. That's 1.4859 times 500. $742.97. So in this case, it grew really slowly because of the low 2%. What we find with compounding and discounting is that small changes in the discount rate can make huge impacts. The difference between 2% and 3% isn't 1%, it's 50%. The 3% rate of return is 50% bigger than 2%. You have to think about it that way as opposed to just one single percentage point. Okay? So, if we said, hey, you are going to receive, I don't know, we'll make it your great uncle, your great great uncle. This person barely exists. Someone you've never heard of. Find out they die. And they left you $10,000, but you don't get it for 10 years. So then, I know the future value. I want to find the present value. So if I know I'm getting $10,000 in 10 years, what's that worth now? Well, I have to choose an interest rate. And this is where choosing that discount rate comes into play. And the trust is rock solid. You're getting the money. There's no doubt about that at all. And what you're trying to understand is, how do I value this $10,000 compared to today? Because that asset that's yours in 10 years is an asset that you can actually sell. There are companies that will take that. They'll give you money today, and you relinquish the payment in the future. So you pick an interest rate of 6%, 0.06, and it's in 10 years. We can just solve for the present value, and all we do is just move this term over here, divide 1 plus 0.06 to the 10th power, and that gives us our present value. So really the formula is the same. The book says that the present value is equal to the future value divided by 1 plus I to the n, but really it's just rearranging the formula. So we can do this quickly. 1.06 to the 10th power is 1.79, 10,000 is, so my present value is equal to 10,000 divided by 1.79, according to my calculator, $5,584. That seems right. Okay, this will be good fodder for questions at 9:30. We'll see you then.